presentation. So welcome along to the March 2023 meeting, folks. And tonight we're going to be getting a presentation from the University of Sydney Rocketry team, Adnan and Vismay, and they'll be talking about their operations and some of the projects that have been carrying on over the last few years. So I was actually thinking about inviting both of them a couple of years back, but of course the pandemic kind of made life a little bit complicated. And in this case, maybe the delays will be worth our while, because we're going to get some information that we probably wouldn't have got from them if I got them in the first time I was thinking about inviting them. So that's great. Okay, so thank you very much to both you, Vismay and Adnan, and I look forward to hearing your talk tonight about the team and what you're doing at the moment for Rocketry.
Okay, thanks so much, Wayne. So thanks everyone for having us here, and we're glad to present what we do and all the projects that we do. So just to start off, let me share my screen. I'm Vismay. I'm the Executive Director for USyd Rocketry team. And I've got with me Adnan. So Adnan's our aerostructures engineer for our next rocket. And a little bit what we do is we effectively, in the name, we build rockets. And we build all the little bits here and there that go within a rocket. And we go to international competitions and compete against a whole bunch of other different teams, different universities all across the world. And the biggest competition we go to is called Spaceport America Cup. It's the world's biggest international university rocket competition. And there's about 150 different teams that compete in there from about 30 different countries. So it's a very big event, which we compete in. So I think we'll just give you a little brief explanation about what we do and our previous project called Blue Red. Before I do, I just want to acknowledge the traditional owners of Australia and recognise a continuing connection to land, water and culture, and pay my respects to elders past, present and emerging. So this is our beautiful rocket called Blue Red. So this is a 3.2 meter long rocket. It's about 5 inches in diameter. It's a little bit more than 5. I think it's 5.5. And this rocket flew twice, once in Australia and once in the competition overseas. So I'll give you a little bit of a brief around our project journey. So this rocket we built in about 12 months, starting in about August 2021, and we led on all the way to June, July 2022, following the completion of the competition. First off, we start with modeling of the rocket. We want to make sure that we can design a rocket from scratch that meets all the characteristics that we need, and it can also ensure that it can meet the competition deadlines and the competition rules. So you can see here we have a different mesh of the fin that we have on there. The fin acts as a support structure, and what it does is provide stability to the rocket during flight. We also see how we can get the drag coefficients of the rocket that we simulate down on the bottom, and that's simulating it through a variety of different airspeeds. And then obviously we've got a little graph of where the rocket flight is. So you can see it's got the altitude of the rocket. So this is the predicted altitude of the rocket. And we run our own simulations for this. So what we do is we made our own flight simulator called Ironbar, and we optimize our rocket through this software to reach 30,000 feet on the dot. So the entire premise of the competition is to hit 30,000 feet using a commercial motor. That's what we call COTS. And so we have to simulate our rocket to make sure we hit it exactly on the point. And then you've got there, obviously, the acceleration and velocity that comes with this rocket. From that design that we had, we spent about 6 months designing our rocket on paper. We started manufacturing things. So what we did is we made different molds for the carbon fiber and the fiberglass, and we hand laid these up. So we did these all by hand. This is one of the things that we really like doing on the team, is making sure that we get as much hands-on experience as we can. This is one of the things that we do to extend our learning from the University of Sydney. So we make everything from the flight computers, the payload on board, the airframe, everything apart from the motor, we try and make ourselves. So we spent about 3-4 months making our entire rocket. We got the help through one of our sponsors to make the airframes. We got this nice, lovely painted and everything. and got it ready for a flight. So before we do sort of fly anything, or we do launch anything, or we do any tests, we have to make sure that what we've built is very safe. As you probably see with like a lot of commercial and industry people, they test their rockets and they test their components on the ground first to make sure that it's nice and safe before they fly in real life. So what we do is we grab pieces of our airframe and we compression test them and shear test them. We want to make sure that these can withstand the loads that we predicted the flight to do. Because the last thing we want is a rocket to start flying out there and it starts shredding to pieces because it's not strong enough. And then we will obviously ensure that we've got the right code, the entire software is really robust, so that during flight, if there's any changes to the rocket, the system can handle it and it can withstand any of the changes that it experiences. From there, we also do some ground testing. So this is what we call deployment testing here. Effectively, what we do is separate the rocket into two different pieces. We do this to ensure that the parachutes can actually come out during the flight. Our rockets obviously have to come back down in a nice safe piece. So we do this with two different parachutes, one that's at the top of its flight and one that's during at about 1,000 feet. And this is so that we can get the rocket safely, as it's one of the points that one of the big points that we get during the competition is a safe recovery of the rocket, making sure it's flyable again. We make sure that all of our rockets, when we design them, that we can fly them pretty much an infinite amount of times. We only have to change a couple components before we can. After we do all of our ground testing and everything like that, what we did was we prepared for a launch last year. So we prepared to head out to a little sheep station near Broken Hill called Solano. And what we did is we spent about a week preparing a rocket and getting it ready to launch. We spent a couple of weeks before that actually dry testing our rocket, making sure that everyone was safe, everyone knew how to assemble the rocket. And then we headed out there. We had a little complications with the weather, but we went well with it. And then we assembled our entire rocket. And then from that, we launched Blue Wren. So Blue Wren hit an altitude of 31,500 feet in the outback of New South Wales. And this had a phenomenal flight. It reached the altitude, all the deployments occurred properly. It performed as we expected. So it performed really well. From this, we learned a lot of information about the rocket, knowing a lot about the flights, so we could go back to our simulation software and optimize the rocket here and there to make sure that we actually won the competition through the altitude. So you can see here, the rocket came back safely in one piece. You can see the parachute here on the right, and it's coming down at a nice speed. And then here it is on the left, all in one piece on the ground. You can see how we're a little excited to see our rocket come back down. From there, we headed to Spaceport America Cup. So we call that SAC. So a group of about 16 of us headed out to America. We headed to New Mexico, and we took our rocket with us in the plane. We had a little complications where some of our bags went missing, but in the end, we got out all of our bags. And unfortunately, that meant that we also lost our rocket components, which are pretty critical for the rocket itself. So from there, we assembled our rocket in front of the judging committee. So there's about 50 or so judges who judge our rocket and design. They critique us from our design choices. They judge us on how the different components we use. They judge us on what components we select, why we chose specific designs. So we got judged heavily by the judges, and they really loved the paint scheme that you can also see on there. Hopefully you guys can see a little bit of the paint. So just a little bit of context before I move on. Our rocket's named Blue Wren because we name all of our rockets after native Australian birds. In this case, it's named after the superb fairy wren called Blue Wren. We had our previous rockets called Silver Eye, Firetail, and Bronzewing. And so we just like to keep the tradition moving forward. After we had these little flight safety reviews and making sure that the judges were happy for us to launch our rocket, what we did is we headed out to the launch site. There we got our final confirmation. You can see on the bottom, our previous executive, Alison, she's signing the flight card off, making sure that they're all happy to launch the rocket. And then this is the judges doing their final checks, making sure that they're happy for us to launch. Unfortunately, this day got rained out, so we didn't have the opportunity to launch, but we went the next day and we assembled the rocket. We all woke up at around 4 a.m., headed out to the launch site in the middle of New Mexico, and we got our rocket assembled. At the after about 3 or 4 hours, we got this rocket nicely assembled, and we headed out to the pad. So obviously here we wear full protection because we are dealing with explosives here. And what we do is we put this rocket on the pad and we arm the rocket. So we take all the pins out, we take all the explosives, safety mechanisms out. And what we do is we get it ready. So all the computers on board are armed, the motor is ready to fire, and it's about a couple seconds before we are ready to go. So after everything is safe, after everyone leaves the launch site, we all retreat back a couple 100 meters, about a kilometer, and each rocket goes one by one. You can imagine there's about 150 teams. So there's about 150 different rockets that are getting launched at the same time. Well, not at the same time, yet they're getting launched one after each other. So after we were the 13th rocket to launch.
8, 7, 6, 5, 4, 3, 2, 1.
So that's a little bit of the beginning of the rocket, and you can see that we're all pretty excited to see our rocket launch for the second time. And then obviously after we launched our rocket, so this is it during flight. So we had a little glimpse of it as it was going up, and it looked wonderful when it reached up. We actually didn't know what height it reached, well, the actual altitude of the rocket it reached. We were skeptical of how good our numbers would be, but once we got our rocket back, about 4 or 5 of us went out to go collect the rocket in the blistering heat of the desert. Unfortunately, we had a black rocket, so our rocket got very, very hot trying to touch. But on the way back, we opened up the flight computers, and the biggest point scoring of this competition is how close you get to your altitude. So we're 30,000 feet, so about 9.2 kilometers. And due to all our simulations and due to all the hard work of everyone on the team, we achieved 29,933 feet. So we're about 67 feet away, roughly about 20 meters from our target goal. So we were the closest in the history of this entire competition to reach this target goal. So that's one of the little proud moments that all of us can have to say. And then, of course, we got back home and we wanted to see who'd won the entire competition. We'd won the little competition for our payload. So our payload on board was called Callistoman. It's a space junk capture demonstration. And what it does is sort of predicts where space junk is and goes to capture it using a robotic arm. So you can see this on the top right. From there, we spent a long couple hours in one of the labs here at uni, and we watched the award ceremony. So we came home winning first place for the payload challenge. So this is for our payload that we had on board. We also came first place for the rocket category, 30,000 foot COTS. And then due to all the hard work that everyone had put in, all the dedication that everyone had put in, we'd won the first place. So we won the entire competition as a whole. And we're the first Australian team to win all 3 of these categories. So that's a very, very proud thing that we all have to say for our team. That's probably a lot of me talking at the moment. You probably guys want to see how the entire journey of the rocket works. So I've got a little video up next, though, which I'll play for you guys.
Okay, here comes team number 1, first place. Team number 133.
And the winner of the 30K COTS category is team 133 from the University of Sydney, Australia, with their rocket Blue Red.
And now we will go to the winner of the Spaceport America Cup, the 2022 edition. And the team is Team 133, the University of Sydney.
Fantastic.
So hopefully that gave you a little bit of insight into the entire journey of our rocket. So that's 12 months hard work by everyone on the team to accomplish such a big thing for our team. So yeah, any questions that anyone would like to ask about how our team works, what our rocket was like, and yeah, I'm happy to answer any questions.
Yeah, obvious one. Can I ask one?
Yeah, well, I'll moderate them. Okay, so that's you, Alan. Yep.
Yes, please. Yep, I'd just love to know whether you guys actually were able to walk around Spaceport America while you were there. Did you do a tour of Richard Branson's building?
That's a very good question. Unfortunately, we did not have the opportunity to. The reason being, launching a rocket like this is a lot of work, and it takes a lot of hours to do. So we didn't have any actual free time to just going around. We would wake up at 4 a.m. to get to the launch site, and we wouldn't be back home until about 6 p.m., where everyone would just be really tired.
Wow.
So,
good on you guys. Well done. So proud.
thanks.
Okay, I've got a couple of questions here. So Scott's got one here. It says, he's actually got two obvious questions. He says, how was the sheep station near Broken Hill selected? Is the owner a father or a friend of one of the team? That's the first question. You answer that one first, and then I'll do the next bit.
Yeah, so our previous executive, Alison, and a bunch of other logistics people, they worked hard to find a launch site in New South Wales where they could launch a rocket. So what they actually did was they got a map of all the different air routes for the planes, and they found this little section within New South Wales airspace that had no flight paths. So they cross-checked that with Google Maps and found the nearest sheep station, and they called them up and said, hey, we want to launch a rocket there. Are you fine with that? And they were very happy to do that. So yeah, that's how we found the sheep station.
And his second question is a little bit more facetious, based on, is the sheep station now registered as an official launch site? Because it's now been a success. It's now been a successful launch site. So wondering if they're now, you or them are now advertising as an official launch site.
It is unfortunately not an official launch site within Australia. So yeah, so it is our own launch site that we use, but it's not commercially available. And the process to make it a launch site every year takes a couple months to get approval.
Yeah, I'd probably also make the comment about when you say near Broken Hill, what does that mean in terms of how many kilometres from Broken Hill? Because remember being out west, close to Broken Hill doesn't necessarily mean at Broken Hill. It means probably within 30, 40 kilometres at least. Yeah.
Yes, so we're probably still speaking about 100 kilometres away from Broken Hill.
That's what I mean. So that probably could say close to Broken Hill, but that still means that anything out further that far west anyway. Otherwise, you're getting towards the South Australian border.
Yes.
That's
Can you talk to me a little bit about propellant?
Who concocted it? You know, and when you're in the US, did you blend it yourselves when you're in the US? Were there any problems with supply? I used to build rockets as a boy with using zinc dust and sulfur as a propellant.
Yeah, amazing question. So unfortunately, the rules within Australia right now to make motors is very, very stringent. It's really hard to make your own motors. So what we do is we buy commercial motors. So these are motors that have already been made by like a big industry supplier, and they're all certified. They all have their own characteristics which we implement in. So we don't really make the motors ourselves. We buy them from the United States, and they get shipped over.
Right.
Well, that kind of leads into what Anne was saying too,
Yeah.
because I know you said something that you don't make the fuel, and Anne's question was, how did you deal with the fuel over in the USA? I'm assuming you may have used the same supplier, but you just asked them to send it to a different location, because you did say something about obviously you don't make it, so so it would have been the same supplier, just sending it to you directly over in the US, I would assume, to run it over there rather than you taking delivery here. But the question I would probably say leading into that, when you said that you lost something in your luggage, what, you actually lost some parts, or what did you lose that was potentially a problem?
Yeah, so we lost, we had a little box with a little plastic hard case box that had all of our components in it. These components I'm referring to the nuts and bolts within the rocket, all the little tiny pieces, all the little parts that make the rocket come together. And this was lost, unfortunately. This was left behind at Sydney Airport. And unfortunately, no one could ever find it. They could never find where it was until about last minute when we needed it.
Too late. Get it back over there, obviously. So you had to try to make do. Is that right, or how did you do?
No. We fortunately we found a way to get Qantas to find it, and they shipped it just over in the nick of time in order for us to get a flight approval. Yeah,
it sounded like that could have been like almost like a showstopper, if you could understand the words for it. Yes,
it definitely was. Yeah, it's really hard to find the nuts and bolts that you want in America, because obviously they stock different ones than they do in Australia.
Yes, that was what Marcus has asked a question about. Is the fuel standard and supplied by the company? Does everybody have to use the same fuel, or how does it work with that?
No. So every team is free to use whatever motor they want to use. So there's two different categories. It's called COTS and SRAD. COTS is just a commercial motor. It's called commercial off-the-shelf COTS. And that's, you can go and buy any motor that you want that a supplier already makes, and that's approved to be used in the competition. So each team can go do that. And there's also what we call SRAD, so student research and developed. So that's when a team makes their own motor themselves, and they want to fly that. Unfortunately, it's not really easy to make those motors yourselves in Australia and then ship them over to the US, just with the laws around importing and exporting explosives.
So John's got a question about the team makeup. Now, from what I understand, is all of your team undergraduates, or is there any postgraduates? And what's the breakdown also by discipline? Because I was looking at, there's obviously you'll have different groups, but the other thing I had noticed looking at your team website was that there's actually quite a large number of ladies in your team as well. So probably be worth explaining to people how it works with your team makeup as to what's the breakdown, how that works.
Yeah, no. So in terms of, I guess, students' backgrounds, we have people who are undergraduate students, and we also have postgraduate students. So we have people who do masters and a couple PhDs on the team. So it's a whole wide range of people at the university, not just doing their bachelor's. In terms of like academic background breakdown, so we have people who do aeronautical engineering, mechatronics engineering, so electrical. Then we have electrical engineering students. We also have some people doing civil engineering, mechanical engineering. There's also people who do physics, commerce, law. We also have people who have arts. So we have a full range of people who are on the team from a whole different background of studies. So they're not limited to just engineering. We want to make sure that people who have a passion for rocketry, who have a passion for being in business type, have a chance to do that.
So that's right. So you got different groups in the actual team at the moment. So Yeah, so it is open to basically anybody who's interested in it, but obviously if they've got a skill set, that's it does help in terms of your development and stuff like that.
Yeah.
I think that's answered that.
I have another question, Wayne.
Yeah, I'm just going. Anne's got a question on the controls the onboard computer have, so she's asking questions about that. How does it actually change the altitude? Yeah, you'd have to measure the altitude too. So you've obviously got equipment that records that. So, what does the computer actually do in terms of the control side of it with the stabilization? So give us an idea how that works.
Yeah, so unfortunately, our rockets are called dumb sounding rockets. The reason why they're called dumb is because they don't have any controls at all. So they work by pretty much igniting it, and they work by themselves. There's no sort of control surfaces on board. So there's no actual, I guess, changing in aerodynamics on the rocket. So there's no like active control. There's no changing of the fins. The reason being that sort of takes it away from being a rocket into a little bit of a different category, which we don't want to really enter in terms of defense. So the reason that's why they don't have really any active control on them. Whereas the computer on board, it determines the altitude of the rocket. It determines the height of the rocket. And the reason why it's on there is so it can deploy the parachutes as well, and as well as give us all the data that we need so we can analyze it. So as soon as the computers detect the changes in velocity, acceleration, and the height, it can deploy the parachutes that it needs to. And that's where it records the height of the rocket. And you also had a question if it's spin stabilized or fixed altitude.
That's right. That's to do with the stabilization of it. So, yeah, so you're saying is the computer really doesn't do that at all. It's just controlled through so really it's more designed for probably one for measurement, because in your case, you actually want to find out whether or not, because you're in a competition, you want to see whether or not it's going to meet the laws of physics that you've done your calculations on. And two, it's basically used for controlling the parachute deployment.
Precisely,
so,
yeah.
Right. Okay. Well, that in itself useful thing. And as I think really in other words, your calculations when you actually build the rocket are quite important, because you've got to actually look at all the weights and the laws of physics and things like that, and work out the fuel, and then decide how much fuel you use, whether or not that's going to get you to the height. That's why you were saying you needed to get to 30,000 feet. And that's really what how the competition works too, isn't it?
Yeah. Yeah. So instead of us actually changing the amount of fuel we do, we can't really change the fuel because that's tampering with an explosive.
Change the mass of the rocket, wouldn't you?
Exactly. That's what we do. So we change the mass of the rocket so we can change obviously the height, and we run simulations continuously to see how the changing weight affects the height. We actually assembled the rocket first time round in the competition, and all of a sudden wind speed started picking up and the temperature started changing. So we had to disassemble the entire rocket and then take about 1 kilo off the rocket so that we could hit our target altitude.
Well, see, that actually the launch locations you're talking about too, you'd be taking it to places where hopefully the weather is fairly standard and also not too changeable with not a lot of wind. So if you've got funny weather conditions, that can actually really have a serious impact on how you might fly. And that was the other thing about even when you went up with a large number of, I mean, was there well over another 100 ones went up on the same day, wasn't it? It was a lot. You've got to hopefully everybody's got the same conditions, but I suppose picking New Mexico does mean that you think that the weather doesn't change too much down there. And that's
exactly
the location, because then everybody's subject to exactly the same thing. Okay, somebody's asked me a question about are you involved with the New South Wales Rocket Club at Wayland? Okay, that's the other club. No, I don't think they actually are. They're a totally separate organisation, actually. This is a student-based one. Okay, so Scott, I'm just trying to go through these different ones. Oh yes, okay, this is an interesting one. How long did it take to convince Qantas that carrying a rocket plane is a good idea? I suspect that it was in pieces, but that's probably an interesting part. Yes, when you do the customs declaration and things like that, how do you deal with something like that?
Yeah, that's a very good question. So fortunately for us, back in 2019, our team took a rocket to Spaceport America Cup again. So effectively, Qantas knew that we were bringing a rocket on board because we did tell them that the entire rocket is clean, has no explosive residue on there. It's all in pieces. It's got nothing. It's pretty much a little PVC pipe in essence is what we're taking on Qantas because we assemble everything when we get to the actual launch site, when we buy all the components in America. So
yeah, you're not taking the fuel with you, so that would be a major sticking point, wouldn't it? So that's why I kind of also mentioned that earlier about the fact that the fuel wasn't being taken with you. So because that's kind of like would be a bit of a red flag for people doing that. So I think Scott's also asked the question on the other. Yeah, so there's mainly talking about the standardisation of the software to ensure that people aren't cheating with respect to the measurements that you get back. I suppose that they'd have to do some independent checks to make sure that there isn't any potential dodginess with the info, because really that's when it comes back, that's actually what the honesty system was. Otherwise, it just goes up there, and you don't really know exactly how far. Yeah.
Yeah, well, there's actually two parts to it. So obviously, there's the honesty system. Everyone's here for the competition, so they do want to win it authentically. But also, we have to use what we call a commercial off-the-shelf computer. So everyone has to have a motor that's been pre-certified by the competition, that's been just bought from the internet by a reputable industry supplier. So that's how they ensure that everyone has accurate results. It's verified by the actual supplier, and that no one can tamper with it.
Yeah, so it means there's some standardization. So really that means that when it comes back down to the getting a good result, it then depends very much on how the team responds to building the rocket to make it perform as better than everybody else, so to speak. Then, as you said, they're doing your measurements and calculations correctly so you can get the best performance out of it. It's really then looking at how heavy it needs to be and exactly the design of it. And I think that kind of segues into Alan's question about the nozzle design. How does it work then with that? Are you forced on the particular design for the nozzle, or how does that then work that you do with the actual nozzle itself, the exhaust?
Yeah, precisely. So everything, because it is a commercial motor, we can't really influence the design of the nozzle or anything like that. So everything is pre-made by the industry supplier. So we can't really change the nozzle design on that.
Okay, so that's a bit. Actually, Anne's got a question about what Adnan was doing on the project. I think that's right. Adnan actually had a presentation, I think, at the ASRC about some of his research work relating to that. So, I've got a question. That's true. Yeah, I'll have to get a second.
So, my contribution to the team is not as expansive as Viz's. He basically looks over the entire team and makes sure we're all doing our job correctly. I was more on the engineering and simulation side of things. So my primary focus was on the CFD and FEA based analysis and developing that throughout the project. So that meant using CFD to, inform our decision when picking the correct nose cone, the correct fin configuration, and all the permutations, combinations that sort of come along with it. And I think those people who would have delved in the dark arts of FEA and CFD would immediately know that the biggest handicap you could have is computing power. So one of the focuses moving on to our new project was integrating UCID's UCID's in-house supercomputer called Artemis to help us with our CFD simulations. So on our normal PCs, we could get 32 gigabytes of RAM, maybe 16 cores. But with UCID's supercomputer, Artemis, you could have a lot more RAM, close to 100 or 200 gigabytes, and with as many cores as our hearts can desire. So that was my role within Rocketry.
So it's mainly simulation, in other words. Okay.
Pretty much, yeah.
Yeah, well, I do need somebody to do that as well, because obviously you got to do the numbers, so that's the important thing about it. So everyone's got a different role in it, really, by the look of it, and that's the main thing. Sorry, Lou, I see you have got a hand up. What were you need?
I'm a bit of an outsider on this, so excuse me if my question seems obvious to everybody, but is this competition used more as a showcase for your young minds, ideas from young minds and various things like that? And so are there people watching from the commercial world, and have you been approached for some of your ideas and any commercial opportunities or whatever?
Yeah, well, amazing question. So in this competition, yes, it is both a challenge for students to excel their technical abilities to try and design a rocket that's very competitive, that's cutting edge in a sense. And at this competition, there is all sorts of companies there watching us. There is everyone from Boeing, SpaceX, Blue Origin, you name it, whatever defense company, space company, they're at this event looking for the best and brightest minds so they can get them on their team. So hopefully that answers your first question. Sorry, can you please repeat your second question?
Some of the ideas too, as regards like patenting some of your ideas. You sort of squash my question a little bit as regards using the commercial stuff. You have to seek to the commercial design. So maybe, I don't know, is that on the cards too? Have you got some scope for design, innovation, design?
Yeah, that's a good question. So technically, we don't really have any commercial, I guess, value in a way. We don't really have any designs that are worth commercializing at this state. If we did, there's probably already different solutions already out there by the numerous different industry partners out there. So we don't foresee ourselves commercializing anything that we do in the next couple of years, to say.
Okay, thank you.
Yeah, that's right.
Well, I had one question on the categories, though, just leading into that is, I understand there is different categories for this. Can you give us an idea what those actually were? Because so I understand that there was I think these are classified as sounding rockets, but I don't know if the competition handles other things. And you're also talking about even different categories with those awards there too. Some of it was COTS, and I think there was another category or something you mentioned. Can you give us an idea how that all works there in terms of the competition?
Yeah. So two things. So there's actually two big categories. There's the 10,000 foot, 30,000 foot. So that's the two different height levels that each team can enter. Right. So that's what the first thing they pick. And then the second thing they pick is the different motor categories that they have. So that's the commercial off-the-shelf systems, so COTS. So that's just a motor that you buy from the internet, from a supplier. And then you've got the SRAD, so Student Researched and Developed, SRAD. And in this category, there's actually three different motors that people can make. So you've obviously got the solid motors, so things that were powering like the space shuttle, boosters, and then you've got your liquid engines. So teams making their own liquid engines, and then there's also the hybrid engine. So it's a mix of both the solid fuel and the liquid oxidizer. So those are the different categories that each team can compete in. So they first pick the two up different height levels, and then they pick the different motor category they want to go into.
So you're in the COTS, but there might be some people also on the same day doing one of the other three groups as well. But everybody competes on the same day, or they do the other ones on different days. I suppose there's a lot of rockets they're launching, I suppose.
Yeah. So there's actually about 4 different days that everyone can launch on.
Ends up doing the other ones on different days. Yeah, right.
It's actually just like a first come first serve on a launch basis. Right. So any motor, anytime, as long as you go onto the launch site, you put your rocket on there, you can go. So regardless of whatever motor you do, as soon as you're ready to launch, and they're happy to let you go.
Oh, okay. So that's, yeah. Marcus was asking a cute question about, plans for the future, I think, was the first thing. And if you got plans for the future, as he's suggesting, he's got some suggested names for future names. Wedge-tail eagle, emu, super heavy lift rocket. Well, that's a different type of program. So I think the question is, what are you going to be doing maybe at the next competition? Have you got any ideas already, or what are you thinking?
Yeah, that's a very good question. So unfortunately, our first rocket was called Wedge-tail, so that name is a little taken.
Can't use that.
And emu is a very good name, but in terms of plans for the future, we haven't really solidified anything that we're really doing. So we're not heading to the competition this year. We're taking a little break from everything. Going to a competition every year is very strenuous on everyone. It's very, very, very expensive, number one, and it's very critical. So we want to take care of people's health and everything like that. So we want to take a little bit of a year off and possibly attend next year.
Well, that makes sense too, thinking about it, because I mean, in any case, you could probably start working on something, but you've got some time to potentially do some test launches again at Broken Hill, since you already know where the station is you can pick. So yeah, Anne had a question about the what was it, the payload? Let's go back a second here. Right, that's right. How the payload was operated during the rocket flight, and how did the robot arm operate? Because I think you obviously got a prize for that too. So I'm curious about how that all worked.
Yeah, that's a good question. So our payload called Callistoman, what it does is during the ascent of the flight, so during the boost of it to go to the altitude of 30,000 feet, it doesn't operate at all. It's got sensors on board that determine that, hey, these loads are going to be too volatile for me to work in, so I won't work in this. But as soon as it has its first parachute at apogee, so about 30,000 feet, it recognizes that and it turns on. So all the computers start booting up and everything like that. It takes about a minute for it to boot up. And what it does is it starts having two cameras. So it has two cameras and it has a little pendulum in the middle. And what it does is the pendulum starts swinging. It's a free pendulum. And it's got 360-degree loop. And what it does is it starts swinging around due to the different changes in the altitude and the different forces that are acting on the rocket, which is really unpredictable. We can't really predict how the rocket's going to be behaving at that point. So what it does, it uses two different cameras and a whole bunch of different algorithms. And it uses computer vision to determine where this little pendulum is. And what it does is it locates this pendulum in the 3D space, in a virtual 3D space that we've created in the software. And it tells the robotic arm, hey, it's located at these coordinates. I want you to go grab it now. And what it does is it takes this robotic arm and goes to this location, and it goes and collects it. So what it does, it grapples it together. And this is working very fast during the rocket. So the computer vision is working throughout the entire flight, throughout the entire descent of the rocket. And once it has a good hold on where the pendulum is, the robotic arm would go and capture it. So the actual robotic arm went and attempted to capture this payload, I think 5 to 10 different times during the entire descent. But on the last attempt that it had, it caught it. And as soon as it caught it, it shut down to make sure that it lost power to the motors, and that the motors would have that grip and continue to hold on to that pendulum. So when we went to go pick up the rocket and we took the payload out and took all the framing out, we got to see that the pendulum was caught by the robotic arm.
Right, so that would be also part of the reason why you actually won a prize for that as well, I think. So it sounds like, is everybody doing the same thing in terms of the science behind that, or is that if they've got different choices in terms of what they can do with the payloads?
Yeah, so each team has pretty much free reign over whatever payload they want to do. So you've got teams that have put shrimps and prawns up in their payload and wanted to see their brain behavior in there. You've got teams that have put blood vessels out there to see the different the transfusions, whether that's possible. You've got teams to see the vibration damping, whether that could be possible in space. So there's a whole endless category of what people can do with their payload. It's free reign, so people can choose whatever ideas they want and to see how it works.
Really, the judges have to look at all the different payloads that people are setting up and think about what science they got back, and then work out whether they think that was a prize, basically based on that type of thing. Yeah, it sounds like your payload was quite complicated, and the fact that it did actually work is quite good. So whoever's done the work on that's done some good science, really. Yes, and Tony was just making a comment about the fact that actually I would say the same thing. Dodos and emus wouldn't be a very good choice for the name of a rocket, because they don't have wings that can fly. So we have to pick something that's agile. I think there's probably after another bird. But probably some names would be better than others. So that's the main thing. Okay. So Castle, it's flightless as well, though, unfortunately, Marcus. So it's in a similar family to the emu. So I don't think it would necessarily be a good choice either. I think it's in the same. Yes, it's fast. I know that, but it's the same. It's a similar type of problem, really. It's the same type of thing. It's a large flightless bird. So I don't think so. Yeah. Okay. Thinking we've got any other questions we need to ask. That cockatoo, yes, possibly, but probably galar's a bad choice. But some people might want to be cute and call it after. I think probably the small little birds like that would probably be still a pretty good choice. Something that's that if you're going to name it after it. And you were saying about the color of the rocket as well being black. What type of choice did you have in terms of the rocket color as well? Was that kind of forced on you because of the some of the other things, or you can paint them to different color?
Yeah. So we have free reign as well, or we want to paint our rocket. There's only a couple of things that the competition mandates, which is just markings to ensure that they know this is your rocket. So just like
Yes.
team numbers, university logos, stuff like that. Apart from that, we get free reign over what paint job we wanted to do. So we worked with one of our sponsors, their own paint, to come up with this design, and we think it's a wonderful way of representing the bird.
Well, that's the thing too. You've obviously got the university logo will be on there. You'll have your number, whichever your entry number is, and then you've got the name of what you call the rocket as well. I suppose that's everyone's. Yeah, call it kookaburra. Yeah, that probably wouldn't be too far off the mark. That would be a fairly kookaburra, still sausages from barbecues, right? Yes, I suppose they do too. That's exactly right. But the other thing about your sponsors, I did know you got quite a few. How does they all fit in terms of the helping you build the rocket? I mean, how does that all really work in terms of they give you practical? It's not just financial; it's also components or something, isn't it? So how does that really work, man?
Yeah. That's a very good question, actually. So all of our sponsors help us in different ways. So some obviously help us with financial contributions, but all of our sponsors help us in the support they give us through like technical assistance. So some of our sponsors will help us with the manufacturing phase of our rocket. So they'll help us with how to properly make this system. They'll help us to make the actual component itself. There's also sponsors out there that will provide us all the equipment that we need to make these rockets for free. And yeah, there's our sponsors help us from like the technical support. So asking them questions about our design, to helping us get the equipment that we need, to all the way to helping us take our components overseas and getting them manufactured.
Yeah, so there's different sponsors for different reasons. I think if those people, I had sent you all the link, it'd be worth having a look at the site, folks, and see what Vismay was talking about, the different sponsors, and they all do different things, really. And I suppose some of them may be money, but others would be helping, as you said, with equipment. So you've got a fairly large number of sponsors looking at it, and they all do different things for you, I suppose. Hopefully you can keep them all on in terms of future work too, because I'm assuming that some of them you've been long-standing sponsors for you as well, so it's kind of evolved over a period of time.
Yeah, it definitely has. We've had a couple of sponsors in there since the beginning of our team who have really seen how we've grown, and yeah, we're keen to have them all on board. Continue to make bigger projects.
That's right. So basically, though, I think in terms of your competitions, this is probably the main one you'd be looking at entering to. Was I know that you said there was 2 categories, but it sounds like this is one of the biggest ones in terms of from a worldwide competition, because obviously the number of launches that we're talking about, I don't know which other countries will be doing anything quite like this one, really. And the population of the US means that there would be a lot of people competing over there at the university level, really, wouldn't there?
Yeah, there definitely is. So the US is one of the biggest has the biggest number of teams going to that competition. I mean, it's the closest thing for them for a launch there. It's probably about a 12-hour drive for everyone to get to there, whereas for us it's a couple of hours of a flight ride to get there.
It does. Was there any other Australian entries over there at the same time? Were you the only one that year?
No, we had plenty of different Australian teams, and it's really great to see that there's different Australian teams entering there now. So there's Monash University, there's also University of Melbourne, there's the University of Western Australia, University of Queensland, Australian National University. Now there's also the University of New South Wales, University of Technology of Sydney. So if you can sort of start to think, all the Australian teams are now heading down there.
You did pretty well then, but obviously maybe not everyone's competing in exactly the same category too, I suppose, given the fact that they might decide to go. You said there was about 3 or 4, there's the COTS and then there's the other ones. They could be going in different ones too, potentially. So you're not all directly competing against each other.
Yeah, precisely.
That's right. So that's the other advantage really with that type of competition. That's the beauty of it too, thinking about it. So that's great. Okay, so let's see if there's any other questions we might want to ask. Yes, that's exactly right. So many Australian teams. you did a good job of explaining. So I know that some of the other unis have been. I remember that Monash had been over there before, but they might have also gone the year before. And I'm really wondering how COVID would have had a major impact on people travelling. And certainly last year was a lot better than the previous year if anybody was going overseas. That would have been hard in 2021, but 22 was a little bit more normal. So it's the great thing about that. Okay. Just trying to think if anybody else got any questions they want to ask. I'm more or less run out of ideas, but I mean, it's really great to see what you folks are doing though over there, because you know, there were a lot of work's gone into your project, and can see it now, and you've got the results of it too, which is great. Oh, okay. What bands were used for the comms? That's right. Tony's got a communications question, which is a fairly good one.
Yeah, that's it.
At the comms.
Yep. So I'm assuming you're referring to the communications between us and the rocket and the telemetry data that we have. So we use the 900 millihertz bands, megahertz band. So this is the band that doesn't really require us to get licenses for radio licenses. But we've also got people on the team who do have radio licenses on there, so they are able to communicate with the rocket.
So yeah, he probably knows what you don't have the same problems that some of the licensing would create. Isn't that correct, Tony? Because it's
the main thing that I was thinking about there was amateur licenses. But if you're in the 900 meg band, then you're out of amateur, so you can use as a commercial band, and I think you've got free use of it for haven't you?
Be curious to know whether anybody else is taking a different approach. Well, I suppose that they've taken one which is the safest one in terms of less problems, because
UTS are using amateur bands, Wayne. We examined them and qualified them a few weeks back now.
Well, you said you're actually working, doing some work with the UTS people, weren't you? Were helping.
We examined them and trained them up and put them through their exams and qualified them for amateur bands. And while we were there, we made a couple of suggestions to them. That's all.
Well, Tony's works for an amateur radio organisation, Vismay, so he's just talking about, he's aware of some of the other groups that are doing things. So I suppose that sounds like UTS is thinking about taking something over there this year, but I suppose everyone's got.
They're in the 10,000 foot competition.
That's that. In this case, you said they decided to take this year off, but if some people will go over there again, and even out of all the different competitors you've got there, that some of them may have a year off as well. I suppose it just depends on the situation, really, for each of them, and also probably might even depend Vismay on how many of you at particular level at university, whether or not the year off will help you do you finishing your degree off or various other things. Sometimes there's personal pressures going on there in terms of the travel commitments and stuff like that. Gets a bit complicated if you're all like following you at the same time. That's the other complication it makes. So you mightn't necessarily be able to do that because it's just too hard to get the time off to finish all the subjects off as well. You know, because I should have actually asked what time of year is this actually held in? Which months are we talking about?
Yeah, so the actual competition is held in June. So it's roughly around the 20th of June. So it changes every year.
The break though, isn't it, over there? I think it'd be the shipping.
It's their break. Unfortunately for us, it's right after semester one of university. So last year we flew out the day after exams finished.
Yeah, that's not the best. It's their summer break. That's the reason why they picked those dates. Yeah. Right. Because I think they have a fair bit of time off, but the timing's a little bit different for ours for that reason. It's just to do with their summer, and we don't quite do the same thing. Okay. Well, Scott's got a question about, so did the rocket relay data to an iPad or something so you could watch the flight? Okay, I don't know whether he did that, but you'll find out, Scott. I've just asked the question.
Actually, we had it relayed to a phone, actually. So not to an iPad, to a phone. So yeah, we have both the computers relaying one to a laptop and one to a phone.
Right.
The reason why it's on a phone is obviously when we have to go walk in the desert for about 5 kilometers, you can't really have a laptop out there, whereas a phone it's much easier to.
Yeah,
out where the rocket is.
try and work out where it is. So that's exactly right. So that does actually help you locate. Oh, with regard to losing your baggage, what was that? Oh, you mean oh, you're talking about, hang on, that was Qantas, Alan. They flew Qantas, remember? It does happen. Yeah, so but I think there was something else going on there as well. He said that Vismay said that the particular components somehow got misplaced at the airport before I left, wasn't it? It wasn't actually during it didn't get lost in flight. It actually got lost somehow at the airport. That didn't get sent across.
Yeah, so it just when we checked it in, they never just put on the plane. So it was just somehow left at Sydney Airport, never put on the plane.
Well, I do recall this. Was it Koshi of all people who was complaining? He had an air tag on his luggage, and he went overseas and the luggage didn't. And I think that he was having an argument with the airline company about where it was. And he said, my tag tells me it's still sitting at the airport in Sydney, but you guys don't even know where it is. So that's one problem with the situation. All sorts of things can happen sometimes with mislaying it. You were lucky you did find it, I think, because sometimes it could take, you could lose it potentially. So that's the good thing about it. Yeah. Yeah, it's just one of those things that, yes, the call went over to please fix so Australia can still be. Oh, you actually remember it. Oh, okay, right. So somebody must have set out a plea for it. Oh, okay. Well, I don't remember hearing that one. So you remember it, Alan? Okay.
Unfortunately, it wasn't just our team that lost our rocket components. So Monash University, their rocket as well was left in Sydney Airport, as well as the University of Canterbury in New Zealand. Their rocket was also left behind.
Area, this is starting to be a bit like a pattern here. Actually, the funny thing about what Alan just says is he actually lives in Sunshine Coast. So the fact that he heard about it up there was meaning it got a little bit of coverage.
Yeah.
Queensland as well. So they heard about it up there. Yeah, okay.
That's right. No, they actually went over to TBG. It was TGB is broadcast around Australia, the morning show by Ray Hadley.
Yeah,
so
they
actually interviewed one of you guys. Don't know whether you remember it, Vismay, but he did actually talk to one of you guys saying, hey, what's happening over in America there? What are you guys up to? And one of your crew said, look, we're trying to run a rocketry competition, and fighting against the world. And it'd be great to be able to find those parts. So Ray Hadley did a call out to Qantas and had a chat to them. And yeah, it was big news for that day. That our Aussie rocketry crew, our Aussie rocketry crew really needed that baggage, So yeah, it was the story for the day. Yeah.
It's interesting though, because that makes me wonder whether or not sometimes external pressure can sometimes get airline companies to pull their finger out and find things.
Well, that's right. Yeah. Yeah, exactly. You had nationwide radio going, and Qantas had to answer it. So
right, but
that was some help.
Yeah, and he also said though that they weren't the only ones that lost parts. So it sounds like something goes on here when you're sending things overseas, and whatever happened, it wasn't the only group that lost parts. That's interesting. Story in itself. I'm wondering what's going on here as to how that could happen in more than one situation. It must have to do with the way that they're dealing with the luggage. But they changed the contractors last year. If you didn't know, Qantas did anyway. So I think there's been a few problems with their baggage handlers in general. Wouldn't be surprised that and one guy got himself famously in trouble by dropping somebody's luggage and having somebody take a photograph of it, and that caused him a bunch of problems. So anyway, okay. Well, I think anybody else want to ask any questions now? I think I'm done. But what I would like to do is to thank you both for turning up at this meeting, Vismay and Adnan. It's really interesting you sharing your work with us and telling us about what you did last year and how it all works, because we hadn't really had any clue until I did a bit of research on this recently that this competition was so many people were entering in it and it was so important.
Yeah, no, thank you, Wayne, and thank you everyone here for having us, letting us present.
That's all right. Well, anyway,
Fantastic.
if you've ever
Thank
got
you.
any more news, just get in touch with us and we'll try and plug it. But I appreciate you coming along because we'd always, as I said, I was thinking about inviting you a couple of years ago, but you probably wouldn't have had the good news to tell us at that point, which you hadn't gone over there. And I know that I think you had been over there once a couple of years back, and you weren't as successful, obviously. But as you said, you understand how the competition works, and the teams then work through how to get the best result this time, which is great.
Definitely. Yeah. Thanks again.
Okay, thanks
Yep,
very much.
thanks for
Anyway,
having
if you
us.
want to hang on-
Congratulations.
Thank you. Congratulations.
Thank you.
Thank you very much. And if you want to hang around for the rest of the meeting, no problems, we don't mind. Thank you.
That's right. Thank you. See you.
Thank you. See ya.
Catch you later. Okay. Just see if I can find where my controls are so I can stop the recording. Otherwise, I'll end up with a lot more stuff at the end there than I need.